I'm Kirk Harnack. On This Week in Radio Tech, I'm joined by Tom Ray and Chris Tobin. We're talking about what we saw at NAB and what we left in Las Vegas and what we brought home. Check it out. Join us. It's This Week in Radio Tech coming up next.
Netcasts you love.
From people you trust.
This is TWiRT.
Bandwidth for This Week in Radio Tech is brought to you by CacheFly at CACHEFLY.com.
This is This Week in Radio Tech, episode 126, recorded April 25th, 2012. Kirk nabs Tom's beer. This Week in Radio Tech is brought to you by Telos Systems and the Telos HX1 and HX2 POTS hybrids on the web at telos-systems.com/HX. Hi, it's time for This Week in Radio Tech. I'm Kirk Harnack, your host for the show. I'm glad that you're with us. And the creator of the show. That's me. I created the show. I've always wanted to do this. You know, when I first heard of Leo Laporte doing podcasts, I thought, there ought to be a podcast for broadcast engineers, for radio engineers. That's my own background. And yeah, I'd love to host it. I'd like to ham it up. That's me. I like to be the center of attention, have the lampshade on the head and all that kind of stuff. But I really thought there ought to be a podcast about that. Well, lo and behold, there is. We're at the 126th episode, and I could not have done it without the incredible help that I get from our co-hosts, and of course the people at the TWiRT Network, but our co-hosts. I'm going to introduce them to you. First of all, he's loud, he's proud, he's the best-dressed engineer in radio. It's Chris Tobin from Manhattan, New York. Hey, Chris.
I didn't realize I was that loud, and, well, I'm maybe a little proud. Yes, coming from New York City, it's a great day today. And as president of CCS Musicam, an IP codec manufacturer, as full disclosure for the broadcast, the IPTV broadcast, that's what I do. And I also do some consulting and advising to radio stations on the side, and actually a couple of them here right in New York City.
Well, good deal. And formerly, you've been with CBS Radio and other radio stations as well. So you've got a lot of experience in the studio and at the transmitter site.
Yes, 2 broadcast radio networks, CBS Radio most recently, and a few other things in between. Yes, I've had a good time. And
good deal.
It's a lot of fun.
And the other guy with no less experience, he's been in the trenches for decades. It's our buddy from the Hudson Valley of New York, Tom Ray. Hey, Tom.
I'm not worthy. I'm in the presence of the creator. Good evening, Kirk. Good evening, Chris. Hello, Kirk. Hello, everyone. I'm VP of Engineering at Buckley Broadcasting, WOR in New York, and I've been doing this about 35 years. So, yeah, it's been decades.
It has. Has it been 35 years for me? Let's see. I started doing this when I was about 19 years old. So, do the math real fast. I'm 50. What's 50 minus 19? How long is that? That's 31 years.
Yeah, so I've been doing this since I've been 17, so.
Oh, gee, many. Well, I was disc jockeying when I was 17, 18 years old. I started engineering about 19. So, maybe we'll do a little chit chat about how you learned, how you got started. Did you shock yourself a lot? Is that how you figured out where all the electrons hang out? Hey, our show here is brought to you by my employer, and I thank them so much for sponsoring the show, the Telos Alliance, Telos, Omnia, and Axia. And today's show is brought to you by the Telos HX1 and HX2, and we'll check into those a little bit later on in the show. We had a big, huge event last week. It was the radio and television and broadcast and media industry's big event, the NAB show, the National Association of Broadcasters Expo in Las Vegas, where they have it every year, and they do almost every year. It's been a few exceptions in the last 20 years, maybe one exception. And we had engineering conferences. It's where station groups get their engineering folks together for meetings. For example, the folks at Cox Radio, at their group, they invited us to do a little speaking to them. I know that the Cumulus Radio group was there, and I'm sure the other big groups were all there too, meeting with their engineers, taking the opportunity to bring folks together and talk about their own internal things and where they're going. And then there were engineering conferences. Of course, just prior to the NAB show start was the Public Radio Engineering Conference, the PREC. I've been part of that in a couple of years past. I wasn't this year. And then even on Monday and Tuesday, there were some more conferences going on. Leo Laporte did the Broadcast Minds event. And my colleague, Joe Talbot, who's been a guest on this show, gave a wonderful paper about how you actually implement voice over IP and SIP trunking systems to put callers on the air via SIP and VoIP in broadcast facilities. There were just lots and lots of good papers. The SPE had a board meeting there. And I was privileged to be able to sit in on that and kind of see how that works. So the NAB is this place where folks come together, and they're there for the conferences and for the expo, to see what's on the show floor. But they're also there just to see what is, just to meet, whether it's for conferences or whether it's for their own company purposes. In fact, Telos, our company, we're all over the world. So we had engineers coming in from Latvia, Ukraine, and east and west coast of the U.S. So it was good to have all those folks together. Tom Ray, you weren't able to be at NAB, but I know Chris Tobin was at NAB. Let's take just a minute here, guys, and chat about what was at NAB that you thought was particularly striking. And you don't have to keep it, in radio, Chris, as I know some of your customers are TV stations as well. What did you find that was particularly intriguing there?
Actually, I found the use of smartphone applications really handy. Burke.com, the Burke Technology folks, the remote controls for transmitters, has their ARC Plus series. And it was interesting to have an iPhone app, right? Yeah, iPhone and an Android app. So you can, remote control your stuff and look at things over that platform, which actually I thought was pretty nice rather than trying to do a third-party application and mix things together in your shop. So it's all on one platform. It talks to the unit and it goes. Electrosonics had some nice digital radio mics, wireless microphones, and their technology was pretty cool. Electrosonics has some nice products because they use tuned cavity front ends on their receivers, so you got some really nice quality material. And this
is wireless mics that use a tuned cavity front end. Is that what you're saying?
Yeah, resonant cavity front end of the receivers. The Electrosonics is a plug-on transmitter from Electrosonics, the HM series. Yeah. So complementary receiver that goes with it. They had some nice stuff, and it was really. I've used their digital stuff, and it's really wild what you can do with it now. And that also had an interface that if you get real creative from the IP side, you can do a lot of stuff with it. So those are two things that stood out on that level.
I've been, if I can pause you for a second right there, I'm a little curious about the whole wireless mic thing, because I haven't been charged with buying or using or implementing wireless mics in quite a while. And I know that the last time I was implementing wireless mics, I think a lot of those wireless mics may not be legal for use anymore. They may be on frequencies that have been taken away from the wireless mic spectrum. What do engineers need to be concerned about nowadays? If I'm going to go order some wireless mics, from one of the broadcast suppliers, what am I looking for? What am I going to expect in terms of what frequency bands they're going to be on, or what should I specify?
Well, actually, all of the manufacturers now on their websites have a new chart. Talks about the legal frequencies you can use and the ones that are no longer permitted by law because they're now part of public safety. The frequency bands themselves, I don't have it committed to memory, but you can go to the websites for Electrosonics, C-Tech Vega, Shure Brothers, and a few others that will, Audio Technica and a few other people making wireless microphones. And they have all the information there. Go to the FCC website as well. It's been in effect now for at least 2 years. So anybody purchasing wireless microphones today would be buying them in the proper radio spectrum. There would be an issue. If you still have something in the closet that you suddenly dust off and say, oh, look, I got an old package here. This will work just fine. Stop, write down the frequencies, contact the manufacturer, and verify that is either in or out of the proper bands. Because I do know that a couple of years ago, did have some equipment that was totally illegal. And if I fired it up here in New York City, most likely I get a phone call from one of the local public safety agencies.
I was reminded by Eric Adler that SBE is doing a webinar. I believe it's on May the 2nd. Yeah, it is. 2 to 3 p.m. Eastern time on May the 2nd about TV white space devices and wireless microphones. That's on the SBE.org website. Thanks a lot, Eric, for bringing that to my attention.
Oh, yes.
So if you want to know about wireless mics, there you go. There's going to be a whole webinar about it.
Yeah, the white space has been very interesting.
Now, Chris, you started out also by saying about wireless mics that the digital wireless mics, you can do some really cool, interesting things with them. What does that mean? What would you do besides?
The nice thing with the digital microphone, the digital technology, you're able to operate in a very congested area and still get results that you typically with analog you wouldn't get. Also, the quality of the audio is really good, and you can manipulate it more. If anyone who's done wireless mic operations like I've done for 20 years, you know that you have multiple transmitters, multiple receivers, antenna layouts. Everything affects the slightest thing, and let's see. Again, I'm holding up the plug-on HM series transmitter from Electrosonics, and this device has an antenna that's built into the base of the unit. So it's actually part of the bottom of the unit. So picture this. Let's talk RF theory. I place my hand over the bottom of this transmitter like most people do, and they hold a microphone transmitter arrangement is this. And now what happens? You desensitize or you detune the transmitter. In the digital world, it gives you a little extra work. You can do a little more and get away with some of the artifacts that you have with the analog receivers. That's one of the things. And the other stuff now with the digital receivers, you can network them. I forget what they call it. I think it's Electronet or something. So you can network and look at the performance and the spectrum and built-in spectrum analyzer information, stuff that you typically would have had on some of the earlier analog digital boxes that give a little display and you can see a little triangle and rough idea of what's going on. Now you get more precise. It's pretty cool. I mean, for that, if you do wireless stuff, you can appreciate it.
These digital wireless mics, do you know what codec that they may typically be using? I would think a lot of them may use aptX.
You know what? Some of them are aptX. Some of them just do a straight linear compression system. It's nothing special. And then some people just do some really special codecs they don't talk about. But when you're doing this stuff, you don't really worry about it's really broadbanded. They don't do too much compression, if any at all, as far as audio sampling. That is not AGC, gain compression. So you have very few issues there. The hardest part is finding the right microphone element for the person that's talking into it and getting the proper the sound from that. But the transmitters themselves, the RF link is 99% transparent to any artifacts from the technology.
Hey, Tom Ray, you guys at WOR, you do a lot of remotes. Are they typically wired mics, or do you run around with anything wireless?
No, they're typically wired mics. Every now and then we do use wireless mic, but it's very close range. It's nothing special. But I was on a conference call today with the New York State Broadcasters Association, and I do need to find out more about this. I'm on the engineering committee. And apparently what they were saying was that the FCC is going to require, it's almost like a per-event license for the wireless mics starting, if not later this year, next year, and they're good for a year. So they have to be, re-upped every year, and they want to know where people are and have the frequencies operating, and they're recommending that when you buy something, it needs to be frequency agile.
Wow. Well, do you remember that back in the days when Marty made a 2-watt portable transmitter, and that for most radio station remotes that we did, that was our wireless mic. We didn't depend on the little milliwatt wireless mics, but we had this big honking thing you threw around your shoulder and went out with a wired mic wired to the Marty 2-watt transmitter, battery powered, and then in the van. Station van, we had one Marty receiver, and then that would go feed over to the 25 or 50 watt Marty, the big transmitter that would go back to the station. You ever do that?
The most fun I had with one of those was when I worked in Hartford. The Ringling Brothers Circus used to come in town, and they used to park down at the train yard and parade the animals through the streets of Hartford to the Hartford Civic Center every year. We took one of the jocks and sent him down there, and he got an elephant ride down to the Civic Center. We had built a backpack. We got a backpack frame. We put a gel cell battery on it with one of those 2-watt Martys at the top, gave him a headset mic and a radio, and off he went, and we had him on the air for almost the whole parade. It was great.
Oh, that's great. That's great. I think we used a 2-watt Marty from a canoe on one of these one of these make your own boat races that a rock station I worked for in Lexington, Double Q, did, and we strategically placed a receiving point on a hill that would catch a whole lot of the river action. Chris Tobin, I kind of interrupted your going off on the things new that you saw or interesting that you saw at NAB. Thanks for taking this detour on the mics. I've been kind of interested in wireless mics for a while and where that technology is right now. What else did you have to say about NAB?
Well, I stopped by the Nortel booth, Nortel transmitters, and they continue to advance with their products, the solid-state FM transmitters that they make, as well as the AM. And their user interface, the AIU, I think they call it, is really cool. It gives you all the information, all the parameters of your transmitter, right? A very easy touch screen. You can access it over an Ethernet connection. And now they have a feature. Go ahead.
That is the advanced user interface, AUI. In fact, we're going to have in a few minutes, we're going to have a interview with Chuck Kelly, the one that we interviewed him in the booth, and we'll play that here in just a few minutes. But isn't that a gorgeous display that you can get remotely? The spectral display and the Lissaju L-R and all the transmitter parameters. I think we could call that transmitter porn. It is just like, wow. I wish we had that when I was engineering a lot.
Oh, absolutely. I mean, the information you get at your fingertips, whether it be in front of the transmitter, by your computer, your tablet, your smartphone, it's great. And now they have a feature where the box, when it's in trouble or it has an alarm condition, I'll say, rather than in trouble, actually calls home. It calls to Nortel. You set this up in advance. It doesn't do it randomly. You have to set this all up. And it sends them a snapshot of what's going on. So, when you call for support, they know what's going on. They can look at the history and say, yes, apparently there's been an issue. We're looking at it. You can arrange a few things with them. So the two sides. One, the transmitter design, the engineering that went into it is really smartly done. And then the other side is the customer support. Nortel has turned around and said, okay, now that we've got this great box that most of the time you won't have to worry about is out there, what if? And that in the back end, now they have a user group as well as the support is just tailored to what all of us do in the field. I mean, how many people go to their transmitter site more than once a week? Maybe more than 3 times a month. So, now you have the support capability that can keep an eye on things for you. And it's just great. I mean, that's something new and different. I mean, the technology is one thing, but the customer support, you need it. It always reminds me of the days of when you dealt with Continental and BE back in the early days when you call up and the guys that you talk to, usually the ones who built the transmitter you have. And they do everything about it.
You know what? We better go ahead and get started with a couple of these interviews, guys. This will give us some fodder for discussion, and also let some of these manufacturers explain their product and their things that they're excited about better than I could. We're going to start by talking to Chris Crump at Comrex. Chris has been the sales manager for Comrex for a long time. I got to talk with Tom Hartnett. If you watched our TWiRT show from last week, episode number 125, Tom Hartnett, the technology director at Comrex, was a guest on the show. So we're going to roll tape here. Burke is going to roll it. Comrex from NAB. We're going to switch to me now. NAB 2012, and we're in the Comrex booth. I'm here with Chris Crump. Hello, Chris.
How you doing, Kirk?
It's good to see.
Good to see you again.
It's good to see you too. We are standing here in front of a very cool product that's called.
This is called Live Shot. It's a video over IP codec for television.
For television.
Yeah.
Now, it's got a pretty unusual form factor. Tell me about that. I'm a radio guy, so I need to be educated about this.
Well, when we did research on this, we found that people didn't want to have to carry around a big backpack or a bunch of gear in a suitcase. They wanted something that was camera mounted and very light. So we created this product that is incredibly feature-rich, but in a very compact form factor. It's designed to fit onto the Anton Bauer mount on the back of a camera, professional video camera, and the battery sandwiches on the outside. You connect it to a 3G, 4G Wi-Fi network using this USB extension. You can do multiple devices and give some space between them so there's no RF interference between the devices. Once it's connected to the network, it connects back to the studio and you're able to do full duplex, high-quality audio and video over 3G, 4G, or Wi-Fi.
So this rack mount box is at the TV station?
This is at the TV. This is at the TV station, and it's connected to a wideband wired connection, whether it's DSL or some kind of Ethernet. And you connect your audio-video inputs and outputs directly to this, to your router or so forth. And as I mentioned, it's full duplex. So not only can I send live video back to the studio, but I can get a video return so I can see what the program is that they're feeding back.
Oh, I didn't realize that it was two-way. That's very cool. Now, TV stations are going to use this. What about radio stations? Are radio stations interested in this kind of technology?
Well, the amazing thing is radio is doing video. Morning shows are doing hits on television stations, and they're streaming to the web. So whether you need to do a tie-in with a local TV station for your morning show, you can have one of these in your radio studio and one back in the TV station. Or if you're doing a remote from the Bahamas and you want your listeners to be able to see that, you can attach this to a professional camera and then send that video back to the studio for your web stream guide.
Wow. And so it's Wi-Fi, 3G, 4G, those kind of connections right off the top of that.
Yeah, it's essentially any kind of IP connectivity. It can be satellite as well. Yeah.
Very nice. This is the Comrex live shot. For more information, you can probably go to the web and go to
Comrex.com. It's that simple. COMREX.com.
Chris, thank you very, very much. It's Kirk Harnack reporting from the Comrex booth at NAB 2012.
Isn't that the coolest thing? The size of that thing is amazingly small. Whereas, hey, I do a little bit of work here in Nashville for the Fox affiliate. They've got, I think, the same backpack that the folks at the TWiRT.tv network have. Is it a live view? Kind of a big backpack full of gear. But that little box from Comrex is awfully small. Chris Tobin, you've kind of been involved with radio plus TV. Is this tech really taking off?
Absolutely. Yeah, the technology is definitely taking off. As Chris pointed out, radio stations are doing more video. I mean, I worked at 2 radio stations that did a lot of video. One of them, it still does it to this day, and it's approximately, 12 hours of video a day we did, along with radio. So it's coming around. And the webcasting and streaming that's taking place, as some people have pointed out years ago, it's, radio, TV, it's now multimedia. It's not just one or the other. It's a little bit of both, or we'll use that buzzword that I think Skip Peasy likes to use once in a while is, convergence. And then, it's coming together all around. And the video over IP technologies are like shooting through the roof.
What kind of money in terms of the camera cost do you have to get into before you get to the level of camera that Comrex box is made to fit onto? Not that may, I mean, that may have to kind of drive your purchase. Like, for example, at the TWiRT network, inside the building there, they have a lot of semi-pro HD cameras, and they're gorgeous with the SDI conversions on them and such. But those cameras, and even a high-end prosumer camera doesn't have that battery connector on the back, the Anton Bauer or the whatever the other standard is. Any idea what that costs for a camera?
The other standard is IDX, which is a V mount. So those are the 2 popular ones. The Anton Bauer gold pin and the IDX V mount. Well, the price points do vary considerably. Yes, what the TWiRT cottage is using are semi-pro with the good chips, nice lens, video output is excellent, but it's HDMI. That poses a little problem because you have to have an adapter. To get a camera that has an Anton Bauer mount or a V mount, you're talking, easily $15,000, $20,000 camera. But these solutions that are being offered up are now offering an ability to attach themselves to the camera without being physically attached, as Chris Crum pointed out, with a battery clamp. So like, say, Live View. They have an HDMI input, I believe, on the newest one, so you can take that HDMI from a camera and still get use of the wireless. But when you're talking video, you're talking television, the budgets are much larger than what radio is accustomed to. It's a whole new world as far as a business model. But I talked to a couple of radio stations recently who actually found a way to justify the cost of investing something like $30,000 or $40,000 in a video solution. They figured out that with the 2 or 3 remote broadcasts a month they do, they could offset the cost and get the benefit of web video, work with their local TV station and do a joint partnership. And then before you know it, they paid for itself within 18 months. The guy was excited. The owner was actually explaining to me that he was able to make it work. This is a radio station talking about $50,000 budget.
One of the questions that's come up, and a question we should try to answer if we don't answer it accurately in this show, is folks ask, well, how much bandwidth do you need for HD video? And unfortunately, that's not the right question to ask, because HD video over the air from a digital TV station, isn't that about 18 or 20 megabits per second, something on that order?
Yes, if you do the full SMPTE 291 something or other, I forget what the exact number is, it would be 19.385 megabits of bandwidth. That's on one level.
And that's still compressed. That's not the raw video coming from the camera.
No. Now, if you're talking, you got to put everything in perspective. Radio has never had to do that before. Before HD radio, you never had to worry about perspectives as far as bandwidth. It was pretty much given FM channel is X, AM channel is Y, and that's it. The two never change because it's relatively fixed. HD radio came along, and all of a sudden now you take that X component in the FM carrier and you're splitting it up and you're making all these different little things, and AM is doing the same. And then all of a sudden there's video. And video analog was pretty much fixed. You had one setup. Your audio carrier 5 megahertz in one direction. Your video channel was 6 megahertz. You're done. Here comes digital. Whoa, okay. You want to do HD video? Well, you can do it at 6 megabits per second over a compressed IP link. That'll give you HD. Or you can do the half compressed at something like 12 megabits per second, like my little prosumer camera can do HD at 1920 by 1080 pixels. So now you have to sort of step back and say, what exactly am I trying to apply? And you can't just use the blanket term, how much bandwidth do I need for HD? Because technically...
the concepts that you're talking about here apply to television as well as to audio and radio. And I'll give you the example. We can say that, hey, how much bandwidth do you need for 20 hertz to 20 kilohertz of stereo audio? Well, you can look at the bit rate on a CD. It's about 1.5 megabits per second, and that's for 16-bit stereo audio sampled 44.1 thousand times per second on each channel. So that's 2 channels at 16 bits. If you want to go up to 24 bits of bit depth, then you're a little over 2 megabits per second for stereo audio, uncompressed. Now, you can compress that. You can compress it to 320 kilobits AAC. You can compress it to 128 kilobits per second MP3. MP3 will probably lop it off at 15 kilohertz. And then there are codecs that'll do it at even less bit rate and still at 15 or 20 kilohertz of audio bandwidth. But you're no longer in the realm of pristine linear audio. Same thing with television video. You might have a bit rate, and I'm sorry, I forget what it is, of for an HD, an uncompressed HD signal. Aren't we looking at a couple hundred megabits per second? I'm sure the chat room would know. Now, I'm not talking about the transmitted TV. I mean the raw linear video out of the camera is really quite high, and the transmitted video on a full HD TV station is about 19.393 according to Eric Adler. Raw HD SDI is 1.485 gigabits per second, according to Wikipedia. And then we can have so-called HD video from, Dish Network or DirecTV or from our cable company. And it might be squeezed down to less than a megabit per second, although it's probably something over a megabit per second. So you can, and yet they can call it HD, even though it could be blocky. Motion may be kind of bad. Color depth may be not so great. And yet it's the number of pixels, it can be spread out to the right number of pixels. So we can think about video in those terms as well as audio in those terms. But once you squeeze the heck out of it, this is where I'm going to call Tom Ray into the picture. Once you squeeze the heck out of it, you can't get it back. And it's never going to sound any better. In fact, it'll probably sound worse the more times that it goes through stuff. Tom, you got some experience with transcoded or audio. What's the word I'm looking for here when you encode audio several times?
Well, I know what you're talking about, and I can't think of the word. It's on the tip of my tongue, but what you described basically can be brought down to one word: yuck.
Yeah. So when you start out like with a phone caller on a really bad, G.729 or worse compression digital phone call, and then that ends up going on your AM HD channel or maybe your stream, a low bit rate stream, you can have some messy sounding audio, right?
Oh, well, one problem we have with is with agencies that send in commercials. They send them in the old days, came on tape, not a problem. Now they email them or they put them up on an FTP site, and our minimum standard is 256 kilobits for an MP3 if they're going to MP3 it. We do have a couple of spots running on the air right now that came in at a bit rate of something like 64 or 56 kilobits, and they're bad enough sounding in analog. You put them on the HD channel, they're horrendous. They have a ringing. I call it a ringing. It's like this halo that's around the audio. You can't get rid of it. There's nothing you can do with it. And we've complained, we've howled, we've whined, we've yelled, and the agency just goes, eh. It's like, okay, fine. It's your client. Have a nice day.
And it's not like a bandwidth for a high bitrate audio spot is problematic, like it was, back a decade ago. Or more than a decade ago when we first started getting the digital systems boxes in our radio stations for spot and song delivery. When they came in over ISDN lines, and we've got a lot more bandwidth nowadays. It just doesn't make any sense for agencies to send out spots at low bit rates. Hey,
not at all. And you run into other problems like all of your satellite channels are compressed. So if you're compressing the satellite channel and you put it on the air, and then you send it to the transmitter site on a compressed STL, and then stick it through an HD radio codec. So you have to be careful.
Our rule of thumb has always been, hey, the highest bit rate you can, especially for contribution. Where low bit rates are helpful is when we want to get audio or video services, but in our case, audio services delivered to the consumer over a low-cost channel. And that might be a 3G or 4G cellular channel nowadays. Sure, some of the world still is on dial-up, so that's obviously pretty low bit rate. But that's where the compression belongs. We as broadcasters really need to do everything we can to keep things pristine as much as possible. There are some codecs from Fraunhofer and others that are making low bit rates somewhat more palatable. But if you do that too many times, it starts to sound bad. Let's talk about sounding good, though, and I want to segue nicely into an interview that I did with Greg Oganowski. Now, Greg's been a guest on this show a couple of times. We caught him at the Orban booth where he's talking about some Orban compression technology and audio processing technology. Burke, let's roll that interview with Greg Oganowski.
Hey, it's Kirk Harnack. We're at NAB 2012, and I'm in the Orban booth. I work for Omnia, but they invited me in here anyway. I'm glad to talk to a guest who's been on before, Greg Oganowski. Hi, Greg.
Hey, Kirk.
Oh, switch hands.
Switch hands.
Good to see you.
All right.
We're talking about streaming, and Orban makes plenty of streaming products. You're kind of in charge of that division, aren't you?
That's what they tell me.
And tell me what we're looking at here.
This is our Optimod PC, which is the audio signal processing to get your stream to sound pro. And we've got the software that controls it over here. And we've got a demonstration of a player.
The Orban Passionate Purple Flash Player.
The Passionate Purple Flash Player. There it is. That's on the Orban website. It's our eval player demonstrating HEAAC, which is the codec of choice these days.
Oh, and being flash, that's just not something that folks would download. They just play it right there on
their
browser.
They just play it right there on their desktop.
Okay.
Plays on the desktop. Plays on mobile apps such as Streams Hi-Fi Radio, which is now available on the Pioneer app radio, so you can control it on the desktop or on the dashboard rather. And that's the size of it. You get Hi-Fi with high efficiency AAC. Yeah.
Now you're a big fan of this codec, right? The say the letters.
HEAAC.
And there's a V2?
It's high efficiency AAC. It was the codec of choice with Apple iTunes.
Okay.
AAC was.
AAC, yeah.
Yes.
Yeah.
HE is AAC with SBR, what they call spectral band replication. And it allows hi-fi at bit rates below 64 kilobits.
And maybe something you could address for me in the audience. A lot of the history of streaming to this point is radio stations and others who have streamed have often made two streams, a higher bit rate and a lower bit rate for those bit rate challenges.
Yes, and this can still be done if you so desire. You can run like a 32 kilobit stream, which is aimed towards your mobile audience.
Yeah.
And the reason why that's important very quickly is because the mobile networks, they're crowded places.
Yeah.
And even though, some of the LTE is even capable of upwards of 20 megabits these days, it can't deliver that kind of data throughput consistently. So it still needs to be buffered, and it's very important to be able to keep the bit rates down to get reliable audio.
But this codec, HEAAC, can do just amazing things at pretty low bit rates.
Absolutely. You'll get 16 kilohertz audio bandwidth, which is what it's actually 1 kilohertz greater than what most people are used to listening to on FM radio.
Okay.
And it can be delivered at, as we say, at 32 kilobits. This one here is a 32 kilobit demonstration of it. And its reliability is the important aspect here.
You've done some papers on the design of playback software. right?
Yes.
And I would imagine now you have a software yourself called Streams Plus.
Streams Hi-Fi Radio.
I've got that on my iPad. Love it.
Yes.
And has this got a lot of the same design features in terms of the quality?
Yeah, you build the buffers up so that you can deal with bad internet, as it were.
Yeah.
You build the buffers up, and it'll give you a reliable stream that'll play for hours, if not days. And it's pretty amazing. We were actually the first company to license HEAAC back in 2002 for streaming.
Yeah.
And we've been on a crusade to get it accepted ever since. It's now accepted at Apple, Adobe Flash, and Microsoft Windows 7 and 8. And it's destined to replace MP3 and WMA.
So for more information, white papers, how engineers can find out about this,
www.orban.com.
Okay.
Yep, it's all there.
Craig, thanks very much for being here. I appreciate it.
Thanks for the opportunity.
Good to talk to you. It's Kirk Harnack at NAB 2012 in the Orban booth.
And that guy is making my throat hurt with that grovelly voice from the too many days of talking. So Greg Oganowski, big proponent of HEAAC V2, and I can understand why. It is a wonderful, wonderful codec. A lot of radio stations are using it to stream, and other netcasters too, using that codec to stream. Chris, what's been your experience in terms of streaming hardware? Have you gotten to use some of the Orban hardware for your streaming activities?
Oh yeah, absolutely. Yeah, we use the PCI card. It works really well. The older version was a PC 1100, I believe it is. Version 1 and 2 and all the latest ones. Actually works really well. Again, with the streaming audio, as Greg pointed out on one of our netcasts, it's how you approach it. Everybody's accustomed to always turning the knobs to the right for more positive or increase in control. I still am learning more and more that when you're doing digital audio, even video, but audio right now, and say the Orban card, the Optimon card, you got to start at 0 and actually go to the left, go downward, because I know it sounds funny, but it's true. It's amazing how much control these devices have. Even the Omnia products are the same way. I've used the Omnia stuff for streaming as well, and it's just powerful. And I tell this to who did I tell this to once recently? Because somebody liked the way I did one of the streams we did at CBS, and he calls me up and was like, "I don't know what you're doing, but it sounds great." And I was like, "Well, you're going to hate what I'm doing because it actually goes counter to the current thinking."
Really? Really?
And as a matter of fact, we were using the Omnia streaming stuff, and I actually had mentioned it to Frank Foti. I told him when he was in New York one time, and he laughed because he said to me, "He goes, well, that's pretty much what you got to do." He goes, "It's exactly it. You got the tools, the power." It depends on how you approach it, and that's what I've been discovering. I've talked to a lot of folks in this last NAB show. A lot of folks I talked to in our audio booth. It's just amazing the amount of stuff you can do now with all of this gear, and it really comes up to what you're listening to and how you perceive it. Otherwise, like Tom points out, if you do it wrong or just go crazy, it's just the word yuck comes to mind, because I've heard some interesting streams that just don't sound right at all. I'm not sure what they were thinking.
Tom, are the stations you take care of, your Buckley stations, any of them doing anything fancy, unusual, or something we could learn from with streaming?
Not really. We just started streaming with some of our music stations again. And actually, what's interesting in Hartford, we are feeding the encoder out of the HD output of the Omnia 6. And it sounds pretty good on the stream. It really does. Sure. So
because HD is a coded product, so the processing is intended precisely for coding. So it makes sense that as long as the audio bandwidth is appropriate for the encoder, then you'd be great with that.
Oh, it definitely is, and it sounds really, really good. And which once again, I mean, even though it's made for the encoder, you think putting processed audio into this, you might want to make it a little lighter. Sounds really good.
All right. Hey, we're going to take a break, and when we continue our show, we're going to be interviewing with Bill Harlan from ERI, and I want to tease this just a bit. ERI has figured out the coolest thing for transmitter engineers. For if you've got HD an HD signal along with your analog, there is a very cool way to get this done now that lets you go up in power, perhaps with the equipment that you have. I just thought this was amazing technology, and I'm so glad that ERI has researched and done this. And by the way, we're going to have somebody from ERI as a guest on this show in the coming weeks. It might be Bill, might be Tom Silverman. So just stay tuned for details on that. Right now, though, it's time for the commercial announcement. And I want to tell you who's making the show possible, pays for some of the bandwidth and pays for some of the gear that we use, and actually puts a little bit of jingle in our pockets. It's my employer. It's the folks at Telos. Now, Telos has for years and years and years, Telos sold this Telos One hybrid. This is the one that Steve Church invented. It was his baby, and he took an analog hybrid and made it way better by adding DSP, digital signal processing technology, to it for putting just ordinary POTS phone calls on the air. And so there are tens of thousands of Telos One telephone hybrids on the air in use all around the world every day. Well, there's a successor to the Telos One. It's the Telos HX1. And its dual two-line companion, the Telos HX2. So if you are in need of a telephone hybrid, that is to put a POTS line into any audio system, whether it's a conferencing system for a conference room, maybe you need to bring in some shareholders into a conference situation. Well, you can take this Telos HX hybrid and you can call into the conference bridge that maybe all the shareholders are called into. And then the folks who are in the conference room, the board of directors and the CEO, why they can hear what the callers on the conference bridge have to say, and vice versa. The conference bridge listeners can hear what the board of directors is saying. And one reason this works so well is there's a number of features that are built into the HX1 and its companion HX2 that allow for really clear communications. One of those is the ability to cancel echoes coming from the studio side. So you can have an open mic and an open speaker in the studio, and it won't feed back. I've been in a radio station where we took the station microphone, not unlike this one, and pointed it put it right in front of the preview speaker that was playing that had the caller audio on. Remember, we're sending audio to the caller with the mic, and we're listening to the caller through the speaker. And by the way, this is full duplex. It's not a speakerphone. It's not a ducking situation. It's full duplex audio. Point the mic at the speaker. The caller did not get any feedback, and there wasn't any feedback in the room. Just amazing technology. The best that Telos knows how to do is in the Telos HX1 and HX2. These will work all over the world, too. There's dip switch settings for every country so that you can get the right ring cadence for auto answering, so you can get the right loop current and the right detection level for dropping a call, things like that. It's all built into the HX1 and the HX2. Needed two lines for conferencing two people together? That's built in to the HX2. So check them out on the Telos website. Call your dealer. Call your favorite Telos dealer. List of dealers is on the Telos website as well at telos-systems.com. And you can look at the HX line of codecs right there. There's a ton of them out there already. All right, let's get back on the show here. Thanks to Telos for sponsoring this. I really appreciate it. All right, guys, one thing that impressed me, even though unfortunately I don't own a station that does HD radio. I know both of you guys do work at stations that, Chris, you have, and Tom, you do, that do HD radio. That is this new, I think they were calling it a filter. I don't know why. I don't know if they were calling it a combiner or not. But this combiner from ERI. So without me messing up the description, let's roll the interview with Bill Harlan of ERI and have a look at this thing.
Hey, I'm Kirk Harnack. I'm in one of my favorite booths. I love this stuff. I'm at ERI, Electronics Research Incorporated. They make like this big brass stuff that transmits lots of power. Antennas, and not only antennas, but ERI also makes things like filters and combiners, and they put together whole big systems for broadcasters to get their signal out all over the place. I'm talking to my friend Bill Harlan. Hey, Bill.
How are you doing?
Oh, yeah, I'm good. I walked in the booth, and you were so excited about something new that is not an antenna.
No.
It's not coax.
It's not coax.
It's a thing you called a what?
An all-pass filter.
All-pass filter.
It's a high-efficiency diplexer, which combines the analog and the FM digital signal together.
Yeah.
And it does it with much lower loss than the 10 dB hybrid injectors we've been using.
Well, now, let's explain that for a second. To do HD radio, one of the most common ways to do it was to take your FM antenna,
yes,
and buy an FM transmitter.
Yes.
Take your HD transmitter and combine them together, but there's a very lossy process.
And you throw away 90% of the digital power.
Right.
And with this, you only throw away 12% of the digital power.
So this filter is sophisticated, innovative design? What?
It's an innovative application of notch filter technology that's really comes out of our high power combiners, like the ones we do at the Empire State Building.
So the trick here is you're combining two signals that are on the same center frequency, right?
Essentially on the same center frequency. It's in-band, slightly off-channel radio.
Yeah. So the benefit for an engineer, a station owner, specifically is what?
If you're running the 1% IBOC power that you're allowed that you can do with a 10 dB injector, you can remove that 10 dB injector, install one of these, and get to almost minus 10 dBc without buying a new transmitter.
Whoa, now, okay, so a lot of FM HD broadcasters are going up in power on the HD because they're allowed to.
They're allowed to, and it gives better building penetration and better coverage for the HD2.
But you're saying they don't have to buy a new transmitter to do that?
No, they just have to replace their 10 dB injector with this new
Oh my, what a revelation. That's amazing. Wow. So tell me, if you could, a little bit about the technology that makes this happen. I see a lot of curves here.
Well, this is measuring the group delay.
Okay.
And this group delay is within the ubiquity specification.
Okay.
And for the analog, it's correctable, and this shows the insertion loss. And instead of 10 dB for the digital, it's only 1.4 dB. And instead of 0.5 dB for the analog, it's 0.3 dB.
So this means that your analog transmitter can breathe a little easier. And you can upgrade your HD to the new
higher power levels that have been allowed.
Certainly to minus 14 and maybe even to minus 10.
Even to minus 10.
Good deal. Bill, thank you very much for this explanation. If broadcasters and engineers want more information about this kind of tech, what's the website?
www.eriinc.com.
Okay. Good deal. Thanks, Bill. Appreciate it.
Thank you for coming by.
I'm Kirk Harnack at the ERI booth at NAB 2012.
You know, there are different ways to combine HD and FM for transmitting out to the audience. And probably the most popular way has been what they call high-level combining. And that's what Bill Harlan's talking about here, high-level combining. Tom Ray, you operate an FM in Hartford, don't you, that's got HD?
Oh, we got an FM in Hartford, and we got an FM in Monterey. The Monterey was using what's called mid-level combining. With a 6 dB combiner, we've got two transmitters. The analog transmitter does, if I remember correctly, about 7.5 kilowatts. The HD transmitter makes up with about 2.5 kilowatts to bring it up to 10. On the analog, and then has the HD signal on top of that. In Hartford, to go up to minus 14, we ended up using the backup antenna on the tower and feeding the HD transmitter into that. But previously at minus 20, we were running with the typical minus 10 high-level combining. And, there was just no way the HD transmitter was going to do that. We need, silly as it sounds, oh, Lord. We need to get set at minus 20 to get 75? Yeah, 75 watts of power to the antenna. We were putting 750 watts out of the transmitter. So, yes, we were throwing 90% away.
Yeah, that's what a 9 dB combiner will do for you.
And our minus 14, and our minus 14, if I'm not mistaken, if I remember the numbers right, it's 385 watts or somewhere in that ballpark. And, of course, that transmitter doing 750 watts was only rated for about 900, so it wouldn't do it, to get 307, let's call it 375. To get 375, we would have needed 3750, and the transmitter just wasn't rated for it. So by firing it into the directly into the auxiliary antenna, we're now putting out 380 or something watts of power, and we're done.
And that's what they call space combining. And for those who are listening to how this works, and you guys jump in, correct me here where I'm wrong, but there's several ways. Here's the goal. With HD radio, the goal is to provide to the listener's radio the proper analog signal like you've always done in the past. And along with that, on either side, tucked right in to the analog signal, to the edges of the analog FM signal, tucked right in there are the HD carriers, and these carriers are very close in frequency. It's called in-band on-channel, but it's really in-band almost on-channel on either side, plus or minus, of the analog FM carrier and its sidebands. And there's a physical problem with. It's hard to get a single transmitter to make both signals. It's very inefficient because the digital carriers have to be produced in a pretty linear way, whereas the analog carrier can be produced by a Class C or very nonlinear amplifier if we filter things afterwards properly. So it's two very different transmitter technologies that just don't like to live together in the same transmitter. Yes, Continental and maybe some others got some things to work in this way, but the typical application was not that this was done in the same transmitter. A mid-level combining, that was kind of an interesting compromise that had some efficiencies where you use one transmitter fully analog and another transmitter next to it was part analog and part digital. And then by combining these two together, you could do so with less than the 9 dB of loss. Tom, I think you said 6 dB combiner. So you're still throwing away, some power to a dummy load, and then most of your power, at least a goodly portion of it, would go up the antenna, and you'd be sending both together. Another way to do it was called space combining, or is called space combining, where you'd have one antenna is sending out your analog, and another antenna, presumably on the same tower, presumably with a similar transmitting pattern, is going to be transmitting the HD signal. And of course, that's very efficient because there's no loss in a combiner. There's no power being thrown away to a reject load in that case. So it's good, but it does take up more tower space, which you may not have. Two antennas. Now you don't have a backup, or if you do have a backup, then you got to take your HD off if that's going to be your less important one. So it has some disadvantages, and if the patterns aren't the same, then you may run into some areas that in your field of reception where the listeners are, where your signal is actually not a legal ratio between the analog and digital, or maybe folks can't pick up the analog but they can the digital, or vice versa. So there's some interesting difficulties with space combining as well. So the last way is this high-level combining, and that's the one that ERI is kind of solved with this all-pass filter, where high-level combining used to be the most efficient way to do it, or the least bad way to do it, was with a 9 dB hybrid, where the analog transmitter would lose about a dB, a little over a dB of its power to the reject load, and the HD transmitter would lose 9 dB into the reject load. So this was, like Tom said, 10% of your HD transmitter's output would make its way out of the combiner or the hybrid and go to the transmitter. So you had to buy a big honking HD transmitter, and you're going to throw 90% of its RF power into a reject load. Doesn't sound like a very hospitable or smart situation, but it was in some cases the most effective way to get it done. Well, okay, so this thing from ERI is able to combine two transmitters, the HD and the analog transmitter. Remember, they're very close in frequency. They're just right next to each other, and do this with very little loss to either transmitter. I think Bill said 12% loss to the HD signal, which is not a heavy price to pay at all. And I think he said about a dB or maybe less than a dB of loss on the analog transmitter. So, that's not much either.
It's
Chris?
not, and to be honest with you, Kirk, with the high level combining, you mentioned that, or actually we all mentioned that 90% of the HD power goes towards the reject load. Well, to add insult to injury, because that HD transmitter is linear, as you had mentioned, to get that 90% into the dummy load, you're putting a heck of a lot more power into that digital transmitter. Usually, depending on how you were doing it, it could have equaled half, if not almost the full power to the analog transmitter.
So you're saying that the HD transmitter would burn up a lot of electricity because it's not a Class C amplifier. It's typically a Class A or Class AB amplifier.
Right, and then you're taking 90% of its output and throwing it away, or heating the building, or
heating the building, or heating the outside.
It's a good radiator.
Yeah, you bet.
So
it's a great way to keep your hands warm in the winter.
You've been involved, Chris Tobin, with a few HDs yourself as well. What is this all, Pat? I mean, my question: why didn't they bring this out? A few years ago. There must be some pretty smart tech in the design of this filter technology, so that these two signals can live with each other, have acceptable what they call group delay, and as some folks in the chat room are wondering, these two transmitters that are being combined together, they're not allowed to see each other. It's like a guy and a girl on their wedding day before they get married. They're not supposed to see each other. One can, mess up, and the other one's not even aware that something happened. Chris Tobin?
Well, that's the black magic of RF, because you're basically describing something similar to a passive hybrid that's used in television a lot to combine signals passively and pass them through what we will call the same pipe. Well, first of all, we're dealing with ERI. Those folks know what they're doing, and they've come up with some wild solutions. So Tom Silliman and his staff, I'm sure this has been in the works for some time. Whether or not it could have been implemented years ago when HD was coming on the forefront, who's to say? I have done HD at both high level, mid, and I've done, we did the split, we did low level. And I will say, and I agree with Tom, 90% of your power goes to a reject load, which heats the room. And I can say at the one facility I was at, we did use the dummy load in the room for heat. It was entertaining. It was even scarier, though, when people would ask, well, what does this do? Don't touch. There's a lot of labels on it. Just stay away from it. It's fine. And we did about, about 1,000, it was a 2,000 watt transmitter, and all we needed was about 110 watts for the HD carrier. The rest went to a reject load. And the electric bill was quite high. The inefficiencies on one part did not outweigh the efficiencies did not outweigh the inefficiencies of electrical load, and it's wild. So this new all-pass filtering system, I think, it'll be a breakthrough. It'll be something folks should look at. And I'm certain with the way HD is continuing to grow and move forward, we'll see more innovations coming out of the folks at other antenna facilities. Shively has some very smart people, and I'm sure they'll come up with something that works very well.
One other way that some companies have done this, and Shively and I think JamPro introduced, any of the antenna companies could have done this, or maybe they all have, is this combining at the antenna itself, where each antenna bay, and typically this was done on panel antennas, where each antenna bay actually has two inputs. It has one for the analog signal and one for the digital signal. And so the combining is done in a little hybrid right in the back of the antenna bay itself, way up there, up the tower. And that as long as all the hardware up there is right, and by the way, this does depend on the hardware 1,000 feet in the air being right. That always scares me. That you could do combining that way, and it was very efficient.
That's probably the closest to the efficiency you can want. Also remember with coaxial cable, you have velocity factors, timing, phase. A lot of things go on in the RF signal. So when you're trying to combine or synchronize two signals coming out of two different transmitters that do not have locked oscillators, it makes for an interesting development. So yeah, at the top of the tower, at the antenna base itself, combining the signals into, say in this case, a panel antenna, was probably the best way to go. But unfortunately, in some applications or some locations, as Tom would know, antenna sites just couldn't support that. If you had multiple facilities in one particular place, I doubt you'd be able to do that very well without making a mess. So I think that's why the high-level stuff and some of the low-level injection was being pursued.
Well, that and one good lightning strike would ruin your whole day, let me tell you.
Well, that too, yes.
I'm always, having to deal with towers and tower crews and antennas up on the tower, and the most expensive problem that you can have is one that's 350 feet or 1,000 feet or 1,500 feet up a tower, because I can't fix it. I've got to call a crew in to fix that. And personally, I'm the kind of guy that likes to have the least amount of hardware up in the sky as possible, the least number of bolts and the least number of bullet connectors, the least number of things to go wrong up there. But that's just me. And hey, when you I mostly engineered for Class A, 3 kilowatt, 6 kilowatt, maybe a few Class C3, 25 kilowatt stations. And I'm sure the antenna companies, would some of them might disagree with this, but I'd rather have less hardware up there and more oomph down on the ground where I have access to it. Is that reasonable?
I think that's more than reasonable.
Absolutely.
We had speaking of hardware up in the air, I had a situation at one station once where we had a panel antenna which was kind of shaped like an X with the elements, and one day we had this little issue, and all of a sudden the reflected power went up and the compressor was running constantly. We sent a tower guy up. There was a TV antenna above it. A piece of ice had slid down and hit the lower arm on the antenna. Pulled it away just far enough so that the element filled up with water. He came down with the element. Honest to God, there was an ice cube this big and this big around. Was not a lot of fun. Speaking of expensive repairs.
Well, speaking of the power on the ground, let's talk about the oomph on the ground. I got to check in at the NAB show with Chuck Kelly, who's also been a guest on this show, and the folks at Nautel. Nautel what stands for Nautical Electronics, and they I guess they started out making buoys, ocean buoys.
Yeah, Loran C and a few other nautical and nautical stuff. Yeah,
that's right.
Beacon transmitters and.
Yeah, aviation beacons, nautical beacons, and hey, at where I have a couple stations in American Samoa, there is an NDB, a non-directional beacon. This is for aircraft used to home in on American Samoa. There's a 10 kilowatt NDB there. In the U.S., most NDBs I think are 25 watts or maybe 50 watts. They're not much, and they have a little top-loaded antenna. But in American Samoa, there's a 10 kilowatt Nautel transmitter there. That's a non-directional beacon. It's on a very low frequency in the hundreds of kilohertz, like 375 or something like that kilohertz, and a top-loaded a couple of wires spread between two telephone poles, making up the antenna for that. And the modern day aircraft just home right in on that. Of course, they have GPS and other stuff too. But anyway. I digress. Talk to Chuck Kelly at Nautel. They've been doing a lot more than just building NDB transmitters. They've been making just the lovely things. Let's have a look at this. Chuck was talking about a new light version of their transmitter. Let's roll me on tape.
Harnack at the Nautel booth at NAB 2012. I'm here with my buddy Chuck Kelly.
Good to see you, my friend.
It's good to see you. Okay, so I've been a Nautel user for quite a few years, going way back to the mid-'90s.
And we're very proud of that.
Well, yeah. But you've got tech here that you didn't have in the mid-'90s.
Yeah, we came out with a whole new concept. This is an analog transmitter.
Okay, AM or FM?
FM.
This is an FM transmitter.
This is a 10 kilowatt FM transmitter, but unlike all the development that has gone on in the broadcast technology for transmitters in the last 10 years, all of that development's been for digital. We thought, what about the 90% of the people that are buying analog transmitters and only want analog transmitters? Let's optimize one. And one of the things that's really interesting is that when you narrow a design spec, you can optimize things. And what we chose to optimize in this new transmitter is efficiency. And this transmitter is 72% efficient, AC into RF out.
Okay.
And price. And it's about 20% cheaper than an analog.
And that's big news because it's solid state.
It is absolutely solid state. And it has all the features, all the bells and whistles that you could ever have. It is a no-compromise, state-of-the-art analog transmitter.
Okay. Now, this display, this looks really pretty.
Yep. This is the AUI. There's actually a web server built into the transmitter. So it's got an Ethernet jack.
Yeah.
You plug in the internet, and then from wherever you are this is just a browser.
Yeah.
From wherever you are, you get this display, and you can see a spectrum analyzer. You can see impulse response audio listens you. You can read the meters. You can check the logs. You can do everything from here. You can pull up a menu. You can adjust the audio processor. We have an optional Orban audio processor called Orban inside, right in the transmitter.
Built in, okay.
Built into the
Very
transmitter.
cool.
And part of the reason for that is there's also some technology in here with a multitude of audio sources. We can bring in AES EBU, left and right analog, composite, but we can also bring in audio, for instance, over live wire. This is a live wire transmitter. It's completely the second from our company, but the first in the world live wire transmitter. It also has the capability of storing audio on a USB device, and it has a playlist editor where we can actually create a playlist with the cuts on the device and play it right out. So it's got like a complete radio automation in here. Now, that's all cool. That was originally as an emergency backup device.
Right.
But what we've actually done is had people come in and say, well, we want that as the primary audio source.
My goodness.
So what they're doing is we've worked out a relationship with our buddies over at Enco. They have developed an interface for their DAT automation system that instead of controlling sound cards, controls these transmitters.
Oh, my goodness.
Sends out the new content, sends out the new playlists, and then sucks back the as-played logs that are created in the transmitter automatically so they can reconcile with traffic and billing and music scheduling.
Oh, my
So it's
goodness.
a kind of a new dynamic of the whole mode of transmission. That's called push radio. And if you think about it for a second, if you're going to do something like push radio, where can you put the audio processor? There's only one place, inside the transmitter.
At the transmitters,
And that's why it's there.
Very cool. If folks want more information about any of this new tech, where do they go?
www.nautel.com, Nautel.com.
All right, and this is the NV10. And what's the LT?
And Kirk, now you can say you've seen the light.
Jeez. Chuck, thank you so much.
Thanks, buddy.
Appreciate it. I'm Kirk Harnack at the Nautel booth at NAB 2012.
Chuck always makes a great presentation. He's so knowledgeable. Chuck is a fellow ham operator, too, and just a real good guy, excellent engineer as well. So, guys, what do you like about that kind of pretty tech or maybe, visual transmitter porn?
The efficiency.
Oh, okay.
Yep.
The efficiency is great.
Definitely.
When solid-state AM transmitters came out, the efficiency was way up over a tube transmitter. If I'm not mistaken, the 3DX50s we run at WOR are about 90 to 92% RF, AC to RF, so input to output efficient. But they haven't been able to really get that up much above 55 to 60% on FM transmitters, just because of the way the semiconductors work at FM frequencies. Seeing as Nautel took the time to optimize things, 72% efficiency on a solid-state FM transmitter is significant, because the tube transmitters running Class C were running in the 72 to 84% range, give or take, before solid-state came along. So this is it's a dollar saver in addition to being a better performer because of the solid-state electronics.
So I remember that some of the first FM transmitters that I heard of and got my hands on were about 50% efficient from AC in to RF out. That's why so bad for solid state on FM frequencies. Well, it's the devices. The actual transistors themselves are a lot less efficient at that kind of frequency. At the ham radio reception, we got a chance to chat with an engineer from Harris. Why am I not thinking of his name right now? I'm so embarrassed.
What's he do?
Oh gosh, what a senior moment here. Oh, he's a Harris's RF engineer, designs a lot of stuff.
Jeff Mendenhall.
Jim Mendenhall, yes, Jeffrey Mendenhall, and Jeff agreed to be a guest on our show. Tom, I know you have some ins to Jeff as well, so we gotta pin him down on a date.
I'll work on him. He's a great guy. He's a great guy, very knowledgeable, and a lot of fun.
He was a good interview during the ham radio reception, or the Bob Heil party, as it's also known. And so Jeff explained how they've been using some newer RF devices, kind of big too, physically, in FM transmitters. I think it's in the Harris, the new Flexiva line there. So they're getting better efficiencies too. And I think we're going to see these kind of improvements continue. What about that AUI, Advanced User Interface? Man, can you imagine not having to wheel out an expensive or rented spectrum analyzer every time you want to check the spectra of a transmitter? It's built in.
That's cool.
I think it's a great approach.
Yeah.
I think Nautel has decided to break away from just a traditional emission box, emitter, and look at the transmitter as more of a system. And I looked at that, and when Chuck was talking about the push radio, I see a lot of potential. If you're really smart about your facility and you need to do, we'll call it broadcast continuity planning or disaster recovery, that push radio concept, if you really think about it, makes a lot of sense for some stuff. And I think it was a smart approach. I know I talked to their director of sales recently, Gary, I think it's Mantufel, I think is how you say it. And we had a great time at dinner once at a seminar, and we were talking about the way the broadcast industry has shifted and what people think and do, and their approach, Nautel, which, years ago, I did Nautel transmitters way back, and, they were nothing to, look at. People would say, yeah, that's nice, whatever. And Harris and BE was still the mainstay. And then all of a sudden, I don't know, in the last couple of years, Nautel has turned the tide, if you will, and has now made themselves a real competitor. And you look at what they're doing and how they're deploying, it makes sense. And Harris is starting to turn around and do some of their stuff now and getting back into the fray. So, that user interface, the push radio, the efficiency, that's a powerful box. It really is.
Well, I think some of what is driving technology at both of those companies and any company. We had John Bissett on from Elenos, which is an Italian transmitter manufacturer. He was on this week in Radio Tech. Yeah, and he showed us 2 kilowatt transmitter in, what was it? Was it 2 rack spaces?
That was a 3RU, okay. Just about server depth in a chassis. Server depth about 40, maybe 38 inches deep. 3RU and 2 kilowatts. It's scary. I mean, it's really scary. Those of us who've done
That's a lot of power in such a tiny place. Yeah. Man, there's got to be some current going on in there. There's just got to be. So
if something goes wrong.
Well, I did like the way the Elenos was laid out inside, and I've known about these folks for probably 20 years now. I've always thought their designs were pretty elegant. They're Italian, and they got a shoe factory on one side and the dress factory on the other, right? So they make some stuff that's kind of elegant the way it's laid out. But I guess what I'm getting at is these transmitter companies. We sometimes we think, radio's on its last leg. Radio's heyday is over with, and I'm not convinced that that's true, because we see these transmitter companies putting so much R&D into their products. We see companies that I'm privileged to work for, Telos, Omnia, Axia, putting a lot of R&D, a ton of R&D actually, into making products for broadcasters and more generally content providers. And our sister company, Linear Acoustic, also. Chris Tobin, the company that you work for, Musicam, you guys have put R&D into your products too. So we know that there's content providers out there, still broadcasters, but then there's other markets that are coming up as well, internet broadcasters. Any last comments, Chris or Tom? We got to go here shortly.
No, I'm covered. I'm covered.
Yeah, me too. It's been interesting, and wish I could have gone out this year because there's a lot of changes going on in the industry.
Well, Tom, I had a beer for you. How about that?
You didn't bring it back. I'm disappointed.
No, I drank it while I was there.
And you called yourself a friend.
Yeah. It was good, Tom. It was good. All right, we got to run. Our show has been brought to you by my friends, my employer, Telos, on the web at telos-systems.com. And today we talked about the Telos HX1 and HX2. Simple hybrids that cost less than their predecessors and perform even better. They're really the best thing out there for getting a POTS line into any audio system, especially a radio station. We appreciate them very much. And also, Chris Tobin, I appreciate you being a co-host with us from Manhattan, New York.
Oh, you're welcome. I just want to say thank you to those folks, the audience that stopped by the booths to say hi, supporters of our broadcast or podcast, netcast. I'm not even sure what the proper term should be. And also just wanted to say thanks to some of the folks that have sent the emails and questions that I've been answering lately.
All right. And thanks also to Tom Ray for appearing from the Hudson Valley of New York. Thanks, Tom.
Thank you. Thanks for having me, and thanks to those watching and listening. One of the things that I'll be doing in the next couple of weeks, I may have mentioned that I'm putting up a small ham radio tower, and I've had a couple of people say, we ought to take the camera out in your backyard. Well, maybe we'll do that.
I would love to see it. At least still pictures, but some movie would be great of that thing going up. I would love to see that.
Do a time-lapse photography of me falling off. Thank you.
Oh.
No, I want that high speed. I want to see that in slow-mo on playback.
Oh, thanks, Kirk.
All right. Thank you for joining us. We're going to see you next week on This Week in Radio Tech. Bye-bye, everybody.